Assalamu alaikum dear students, and welcome to our series of exploring O-level organic chemistry. In this video we will delve into the various types of formulae used to represent organic compounds. So let's dive in. First of all is the basic definition of the chemical formula. It is the symbolic representation of a molecule or a compound. For example, the chemical formula for carbon dioxide gas is CO2. It shows that it consists of carbon and oxygen element, and in each molecule of carbon dioxide, one carbon atom is covalently bonded with two oxygen atoms. Let's move towards the different types of formula used for representing organic compounds. First is the molecular formula, empirical formula, then displayed formula, structural and skeletal formula. Now we will discuss them one by one in detail. First type of formula is molecular formula. It represents the actual number of atoms of every element in the molecule of a compound. For example, butane is an alkane which consists of 4 carbon atoms. Its molecular formula is C4H10. This means that in each butane molecule, 4 carbon atoms are covalently bonded with 10 hydrogen atoms. Similarly, in pent-1-ene, its molecular formula is C5H10. This means that each molecule of pentene consists of 5 carbon atoms which are covalently bonded with 10 hydrogen atoms. Next is the displayed formula. Displayed formula represents the arrangement of atoms and all the bonds present in an organic compound. These bonds are represented as lines between the atoms in the diagrams. So let's do some example. First is the example of butane. Butane, as its name shows that but stands for 4 carbon atoms and ane shows that it belongs to the alkanes homologous series. This means that it consists of only carbon to carbon single covalent bonds. So I will draw a chain of 4 carbon atoms with single covalent bonds, and all the other bonds of the carbon atoms are made with the hydrogen atoms. Always remember that each carbon atom has 4 covalent bonds. So this is the displayed formula for butane. In this formula, the arrangement of atoms is shown as well as the bonds between the atoms are also represented. Next example is the displayed formula for pentane-3-ol. Pent stands for 5 carbon atoms and 3-ol means that the alcoholic functional group is present at carbon number 3. So I will first draw a chain of 5 carbon atoms and functional group OH at carbon number 3, and rest of the bonds will be made with the hydrogen atoms. Be very careful while drawing the displayed structures of organic compounds. If you will miss any single bond, you won't get any mark for it. And do not forget to draw the bond between the functional group. So this is the displayed formula for pentane-3-ol. Next is the displayed formula for but-2-ene. But stands for 4 carbon atoms. Ene means that it consists of carbon to carbon double covalent bond, and the double covalent bond is present at carbon number 2. So I will draw a chain of carbon atom, 4 carbon atoms with a double covalent bond at carbon number 2. I will number the carbon atoms. Then I will draw all the other bonds with the hydrogen atoms in order to complete the valence shell of every carbon atom. So this is the displayed formula for but-2-ene. Next type of formula is the structural formula. Structural formula represents the arrangement of atoms in an organic compound. So, let's draw the structural formula of propane. Prop means it consists of 3 carbon atoms and ane means that it belongs to alkanes homologous series. First, I will draw its displayed formula so that it will be easy for me to write down its structural formula. The displayed formula of propane is like this. Now I will number the carbon atoms. So, for its structural formula, carbon number 1 is bonded with 3 hydrogen atoms. So I will write CH3. Then carbon number 2 is bonded with 2 hydrogen atoms. I will write CH2. And finally third carbon atom is bonded with 3 hydrogen atoms. So its structural formula will be CH3, CH2 and CH3. This means that first and the last carbon atom in alkanes are bonded with 3 hydrogen atoms and all the other carbon atoms that are present between the first and the last carbon atom, they are bonded with 2 hydrogen atoms only. Next, we will draw the structural formula for propene. First, I will draw its displayed formula. There is a double bond in the chain, as the name represents that it belongs to the alkanes homologous series, and rest of the bonds will be made with hydrogen atoms. So this is the displayed formula for propene. Now with the help of this displayed formula, I will draw its structural formula. First, I will number the carbon atoms. Carbon number 1 is attached with 2 hydrogen atoms. Second carbon is attached with only 1 hydrogen and the third carbon atom is attached with 3 hydrogen atoms. So CH2, CH, CH3 is the structural formula for propene. The main difference between the displayed and the structural formula is that in displayed structure, arrangement of atoms as well as all the bonds between the atoms are shown, whereas in structural formula only the arrangement of atoms is shown. Next type of formula is the empirical formula. It represents the simplest whole number ratio of elements in a compound. For example, the molecular formula for butane is C4H10. So, its simplest whole number ratio of elements will be 2 into 2 makes 4 and 2 into 5 makes 10. So, its empirical formula will be C2H5. Benzene, its molecular formula is C6H6. After simplification, its empirical formula will be CH. Pentene's molecular formula is C5H10. So, its simplified form will be 5 into 1 makes 5 and 5 into 2 makes 10. So, its empirical formula will be CH2. Next is the skeletal formula. Skeletal formula is the simplest possible way to represent the structure of an organic compound. In a skeletal formula, carbon and hydrogen atoms are not shown, only functional groups, the bonds to the functional groups and the bonds between the carbon atoms are shown. For example, the skeletal formula for butane is like this. The point where the lines meet each other represents the carbon atom. The vertices shows the carbon atoms. I will number the carbon atom 1, 2, 3 and 4. The line shows the type of bond present and the vertices or the points where the lines meet each other, it represents the carbon atom. Hydrogen atoms are not written at all. Next example is of pentane 2-ol. So I will draw 5 carbon atoms with alcoholic group at carbon number 2. So this is the skeletal formula for pentane 2-ol. We will not discuss skeletal formula in detail in O levels. However, it is discussed in detail in college level chemistry or in A level chemistry. Now, finally, we will wrap up our today's video by summarizing all types of formulae for butane. Butane is an alkane with 4 carbon atoms. So, its molecular formula will be C4H10. After simplification, its empirical formula will be C2H5. For its displayed formula, first I will draw a chain of 4 carbon atoms, and then rest of the bonds will be made with hydrogen atoms. So this is the displayed formula for butane. With the help of displayed formula, I will draw its structural formula. I will number the carbon atoms from the left side. First carbon atom is bonded with 3 hydrogen atoms. Second is bonded with 2 hydrogen atoms. Third is also bonded with 2 hydrogen atoms. And finally the fourth carbon atom is bonded with 3 hydrogen atoms. So this is the structural formula for butane. Next is the skeletal formula. This is the skeletal formula for butane, in which all the hydrogen atoms and carbon atoms are not shown. Only the lines represent the types of bond present between the carbon atoms, and the points where these lines meet each other, they represent the carbon atoms. So this is all about today's video. I hope you will find it helpful for writing formulae of different organic compounds. Thanks for watching my video. Until next time, stay bonded with us. Allah Hafiz.